All right, guys, I'm ready when you are. Oh, that's a very large pen. Let me see if I can't make that smaller. Nope, it's as small as it goes. Okay. What do you guys need help with? It could be a specific problem from a worksheet. It could be a generic topic. You just got to let me know what it is. What do you guys need help with? You need help graphing? Do you need help with elimination, substitution, word problems? Um, what is that? Linear optimization? Type it into the chat box and I can help you out. Yeah, sure. Do you have one in mind in particular? You want, I can do one from the quiz, from the review. Do you want me to just pick one? Cool. I'm going to do one from the quiz because that is sitting right in front of me. So I think that the one that requires the most work is one that I'm going to go ahead and I'm going to call it triple elimination. And that's a problem where there's 3 variables and 3 equations, and all 3 equations have all 3 variables in them. So the one that was on our quiz was negative 6x minus 2y minus z equals negative 17. And then we had 5x plus y minus 6z equals 19. And then negative 4x minus 6y minus 6z equals negative 20. Okay, and I'm going to put a little box around that to remind me these are my original problems. And so then what we're going to do next is we're going to kind of make an executive choice of just like what letter do we want to eliminate. And it really, honestly, it does not matter which letter you eliminate. You kind of look at the problem and figure out like what letter would be the easiest to get rid of. For instance, I would not get rid of the letter X because 6, 5, and 4 are all very different numbers, and so that's not going to be too easy to get rid of. Most of my classes today that asked about this problem, they wanted to get rid of the Y. Me personally, when I look at this, my first instinct is to go for the Z's because the 2 of them are already 6Z. So it doesn't matter what letter you choose. Since most of my students today chose Y, I'm going to go ahead and choose Y as well, just in case that's what you would choose. So I'm going to choose to eliminate the letter Y. And then another really important thing when you're doing these 3 variable problems is you don't have to use all 3 equations at one time. You are allowed to just use 2 of them at a time. So I'm going to start with the first and second equations, and I've decided that I want to eliminate my letter Y. And so if I'm going to eliminate my letter Y, I need to have the second equation have a 2y, so I'm going to multiply the whole second equation by the number 2. Now, when you're doing these problems, it's really important that you're being careful and that you're just being very aware of your numbers and your symbols. There's some common mistakes I see people make. One of them is forgetting to multiply. So I see a lot of students that they'll multiply the x, they'll multiply the y, they'll multiply the z, and then they'll forget to multiply the number that's on the other side. So they'll still write a 19 there instead of a 38. So just be very careful. We are multiplying the entire equation by 2. And then once you get here, we're doing elimination. We're going to add straight down. Okay. And the y's will cancel. And then I do also suggest tomorrow that you bring a calculator that you're comfortable and familiar with, and that you use it excessively. Again, we want to try to make sure that we're not making silly mistakes where we added or subtracted or something just a little bit off, and then that will throw off the whole problem. All right, so that's what I got when I eliminated the letter Y. And then next, I'm going to kind of ignore what I just did for just a minute, and I'm going to pick two different equations, and I'm going to eliminate the letter y again. So it has to be the same letter twice in a row. I can use the first and third, or I can use the second and third. So it doesn't matter which one, as long as you just don't do the first and second one again. So I'm going to go ahead and do the second and third. And this time I'm going to multiply the second equation by a 6. Okay, so 6 times the entire second equation, so that's 30x plus 6y minus 36z, and then 19 times 6 is 114. Now the numbers here are going to get pretty big, and that's okay. Don't worry or stress if the numbers are looking huge. That doesn't mean that you're doing anything wrong. Hold on one second. Grant? Honey, can you go in the other room, please? I understand, but I need you to go in the other room for reading, okay? Okay, thanks, hon. All right. Okay, so we're canceling out the y's again. 30 minus 4 is 26. Negative 36 and negative 6 is negative 42. And then 114 minus 20 is 94. All right. Next, what we're going to do, we have two red equations, and they both have only x's and z's in them. So now what we're going to do is we're going to take these two equations and we're going to cancel out either the x or the z. And again, it doesn't really matter which one you want to cancel. You get a pick. So I'm going to cancel the x's just because 4 and 26 seem like smaller numbers than 13 and 42. And so you could multiply by something smaller, but I'm just going to multiply by what the other equation has. So I'm going to multiply that top one by 26. I'm going to multiply this bottom one by 4. And I'm going to make it a negative 4 because the x's right now are both positive, and I need one of them to turn into a negative. Okay, so the second one by negative 4, first one by 26. So 4 times 26 is 104x. 26 times 13 is 338. And then 26 times 21 is a big number, 546. Okay, so that was this first equation right here. Now I'm going to do this equation. So 26 times negative 4 should be negative 104. That was kind of the whole point. 42 times 4, and this is a negative times a negative, so that'll turn into a positive. 168. Very common mistake that students make is accidentally writing the wrong sign. And then unfortunately, like, everything goes crazy after that. 94 times 4, 376, and that'll be a negative 376. All right, my x's are going to cancel. Okay, and then now we do negative 338 plus 168, that's negative 170. Then we do 546 minus 376, and that is also 170. Oh, I forgot to write my letter Z. See, silly mistakes. And so now, like, the numbers were ginormous. The numbers were really, really big. But right now, everything's going to work out super nicely for us. Z is negative 1, and that's my first answer. At this point in time, if this was my test, I would go over to the answer line, and I would write negative 1 here. I'd start filling in my answer so that I don't forget to later. Once you have your first answer, it all kind of goes a little bit easier after that. Again, I like to call this method triple elimination. We eliminated the letter y twice. Those are the red equations. And then I took those answers, the two bottom red equations, and then I eliminated a different letter. I eliminated the letter x, and I did that with the gray equation. And now I've gotten my first answer. So 3 eliminations before I can get my first answer. Once you have your first answer, you're going to go back and you're going to use one of the equations that only had 2 variables in it. So I can use one of the red equations. We're definitely not ready at this point in time to use one of the original equations with the 3 variables. So I'm going to pick one of these. I'm going to pick this one just because I think the numbers are smaller. but it doesn't matter which one you pick. And I'm going to plug in my z equals -1. And now I have an equation with only a letter x in it, so now I can solve for x. And I can write that answer over here. Remember that your answers need to be, if you have a question, just type it in the chat box. I can help you. The answers need to be in ordered triple. The order is alphabetical, so X, Y, Z. So make sure you're writing your answers in the correct order. And if you guys have other questions as I'm going along, go ahead and type it in the chat box and I can help you out there. All right, we're almost done. We just need one more letter, and that is the letter Y. So now I know X is 2 and Z is -1. So at this point in time, I'm ready to go back up and I'm ready to use one of my original equations. One of my equations that has 3 variables. So that's the only equation that even has like a letter Y in it. I'm going to choose the second equation, and I'm making that choice because the letter Y is all by itself in that equation, so I think that's kind of nice. And so I'm going to plug in my 2 for my X, and I'll plug in my -1 for my Z, and now I can solve for Y. And that's my final answer. When you're all done with these problems, you can go back and check your answers. What you would do is you would plug these numbers into the original equations up here, and you can just type it in your calculator. So you would type in like -6 times 2 minus 2 times 3 minus -1, and then hit the equals button. And we're hoping that it says it's equal to -17. And then you would plug it into the next equation. So the trick with these problems is the ordered pair or ordered triple has to work in all of the equations. So then you also want to check it in the second one. So you do like 5 times 2 plus 3 minus 6 times -1, and hopefully that equals 19. And then we would finish it up with -4 times 2 minus 6 times 3 minus 6 times -1 and hit the equals button. And again, we're hoping that equals -20. So if you can get if the ordered triple works in all 3 of the equations, then you know that you got the right answer. All right, what else do you guys need to see done? Do you want another one of these? Do you want something different? We've got lots of different types. Well, we actually don't have that many different types, but we've got some different types that we could be doing. I don't know what you're talking about, kiddo. I'm not sure. I don't know the answer to that. Okay. How come you're not in bed? Okay. Shh. I can't do the night-night song tonight, kiddo. Not till 9 o'clock at least. Yeah, we can do another one of these. I'm going to do one that's a little bit different, which is also from the quiz today, and I'll explain why it's different and how we can approach it a little bit differently. I do also want to say that these problems don't have to be done exactly how I'm doing them. And so I'm making some choices when I'm doing these problems about what I want to do, and that's not necessarily that's definitely not the only right way to do these problems. That's just the way that makes the most sense to me. So one of the big things on tomorrow's test is, look at the problem and go with your first instinct, like staring at the problem. What do you think you should do first? And then just kind of keep working until you can get that first answer. So this was number 5 on the quiz. Oh no. This was number 5 on the quiz, and the thing that makes this one a little bit different is if you look at the last equation down here, first of all, it's written in a format where it kind of makes you want to do substitution. And then secondly, it's missing the letter Y. So there's a couple different things that we can do from here. Oh yeah, sure thing. There's a couple different things that we can do from here. We can either substitute this z plus 5 into both of these x's, or we can eliminate the y's, and then we would have a lot of equations with only x's and z's. So I'm not really sure. My first instinct is to substitute, just because that last equation kind of, to me, is screaming substitution. So I'm going to go ahead and do that first. You could, yeah. And again, the reason why I knew that it was kind of easy to substitute on this one is because the x was all by itself down here. That doesn't mean you can't do elimination. You could take the top two equations and do elimination. So it's kind of up to you if you want to do substitution or elimination on this problem. It'll work either way. A lot of my students took the top two equations and eliminated the y's, and then they went from there. And I can show it that way too if you want to see it both ways. All right, but I'm going to start with substitution because it's kind of set up for it. So I'm going to substitute into the top equation first. And honestly, those parentheses were kind of pointless. They didn't really do anything. Okay, so I have a negative y and a 3z, and then I'm going to minus the 5 over here, so that equals 2. So that was the first equation. And then I'm also going to substitute it into the second equation. So I'm just kind of putting it anywhere that I see a letter x. All right, so I have a y and a 3z, and then I'm going to minus the 10, and that gives me a negative 2. Now, if we take a look at these two red equations, they have a positive y and a negative y. So I'm going to stack those on top of each other. I'm going to do that over here. And if I stack them on top of each other, I can do elimination right now. And I want to point out, because a couple of my students had trouble with this today as well, negative y plus y is 0y. They eliminate. But positive 3z and another positive 3z, that makes a 6z. So I had a lot of students who were just they were going a little bit too fast, a little bit careless, and they saw a 3 and a, oops, sorry, I wasn't supposed to write that. They saw a 3 and a 3, and they were like, oh, 3 and 3, those cancel. But we're adding the 3's, so they actually don't cancel, they make a 6. And then on the other side, 2 minus 2 is 0, and we are going to actually write the number 0 there. And right here, also, it's okay to get a 0, and there's still a letter in this problem. There's the letter z, so this would not be a no solution, and it also would not be like an infinitely many, because there is still a letter. Good, and z does equal 0. That's perfect. And so don't be scared if you get the number 0 on the right-hand side of the equal sign. If there's still a letter in the problem, you can keep going, and you can solve for that letter. And I've now got my first answer, which is 0. From here, I can very easily either get y or x, honestly, because we've got some equations with only x's and z's and some equations with only y's and z's. So I'm gonna just choose. I'm gonna plug in the z equals 0 to this equation, and I'm gonna solve for y. And 3 times 0 is just 0, so that goes away. And so now I have my second answer, y is negative 2. And now that I know two answers, like I could really use any of these top 3 equations to find my x. I would say the easiest one to use is this bottom one down here, but you could totally use one of the top 2 if that's where your mind goes. And so I'm going to use the bottom one because it's just x equals 0 plus 5. So that means x equals 5. And so that's it. And then this is my final answer. Okay, so that was one way to do this problem. Again, you could have started it completely differently if you wanted to. You could have started by noticing that the top 2 equations will eliminate the y's. So you could have started like this. And if you don't like substitution at all, you could change the last equation into something different, and then you could just do elimination all the way across the board. Like, you don't have to do substitution at all if you don't want to. If you were going to do that, you would need to minus the z. You can make it x minus z equals 5. And now these two are set up for elimination. Or you could plug this in for that x and solve for, like, there's so many different things you can do. Okay? What is this? Gavin, what kind of graphing problems? Just like straight up graphing, or like, because I'm going to do number 13, which is graphing inequalities. So I don't know if that's the type you're looking for, or if you're looking for something different. I mean, there can be. I think, though, that the so on our quiz we have numbers 13 and 14. I'm pretty sure on the test we're going to have a problem like number 13 for sure. And I don't remember there being a problem as intense as number 14. So I would say if we focus on number 13, that's going to be the best case scenario. So let's focus on number 13. Actually, I'm going to open up something else so that I have a nice graph, because I want to be able to graph. I hope this graph is big enough. It is, okay. Yeah, I think if we just focus on 13, we should be good to go. All right, so let's take a look at number 13 from the quiz. And so I know it's kind of hard to tell because of the way it's typed, but there's actually 4 inequalities. So those last 2 inequalities are written on the same line. I'm going to separate them on here, though, so that we can tell that there's different ones. And so if there's 4 inequalities, we're going to have to graph 4 lines. If you want to, we can start with the bottom 2, because actually those are the easiest. And on a word problem, you should always have these bottom 2. These bottom 2, just make sure that the answers stay in the positive numbers. So x is greater than or equal to 0 just means don't go past the x-axis. So we want to use everything like above the x-axis. And then y is greater than or equal to 0. Oh, nope, I did that backwards, sorry. The one that I drew is y is greater than or equal to 0, because we want everything above the x-axis. And then, why is it so much more difficult to draw vertical lines? For x greater than or equal to 0, that's here. And that says we want everything over here. So basically, those last 2 inequalities, just make sure that you stay in the first quadrant. Okay, and then whenever I'm graphing my in this chapter, I like to change everything into slope-intercept form, because that will get me the most accurate line. And especially on a problem like number 13, you are going to be looking for a point of intersection. And so we want our lines to be super accurate so that we make sure that we get the right point of intersection. If we make the lines to, if they're not straight enough, then we might get the wrong ordered pair. So really important that we get the right ordered pair in this problem. All right, so my first inequality changes to this. So I'm going to start at the 8. And then my slope is -1/1. So down 1 and right 1. And I'm actually, because I know I'm staying in the first quadrant, I'm just going to go like this. And I'll stop when I hit the other axis, because I don't need to do anything other than that. Oh my goodness. Okay, we're going to pretend like I actually connected those dots together, guys, because apparently I can't do that. And then it says 0 is less than or equal to 8, which is true. 0 is smaller than 8, so we're going to shade down towards the origin. All right, so that was this first one, is the green one. And then let's go ahead and do the second one. And again, I like to change it to the slope-intercept form so that I can make sure that my line is like completely accurate. And let's see, let's do this one in gray. Okay, so this one I'm going to start on the positive 10, which is up here. And this one has a slope of negative 2 over 1. So down 2 over 1, down 2 over 1. I've got my point of intersection right there. Down 2 over 1, down 2 over 1, and down 2 over 1. Okay, and then we'll see. Maybe I can actually connect these together. Nope, not going to happen. All right, we'll pretend like that's a nice straight line. And then for this one, again, we get 0 is less than or equal to 10, and that's true. So this one also gets shaded towards the origin. And what usually happens on these problems is you get this, from these two inequalities, you'll end up with this four-sided shape. And it's not like a square or rectangle or anything like that, but it definitely does have four sides to it. And so it always starts on the origin, and then it goes up until it hits its first line, and then it follows that line until it hits another line, and then it changes directions and it follows the other line until it hits the axis, and then from there it goes back to the origin. And it's this section right here. This is what we're concerned with. Okay. And so that's my four-sided shape. And in my four-sided shape, there's four vertices. There's four corners. And so I need to know about those four corners. So one of them is down here. It's 0, 0. One of them is up here at 0, 8. One of them is right here at this point of intersection. My lines are not very straight, but that's at 2, 6. And then the other one is down here at 5, 0. Okay, so we have our four ordered pairs. Now on number 13, it didn't ask you for those four ordered pairs, but we gave you some blank space off to the side of the graph, and that's where you should have written those four ordered pairs down. And then after all of these inequalities, it says that it wants the point to maximize, so that means big, maximize, and then they gave us an equation, P equals 8x plus 2y. So what I would expect to see on your paper next, I would expect to see that you plugged in each of these ordered pairs into here and figured out what it turned into. So like 8 times 0 plus 2 times 0, well, that's 0. 8 times 0 plus 2 times 8, that's 16. 8 times 2 plus 2 times 6, that's 16 plus 12, that's 28. And then 8 times 5 plus 2 times 0, and that's 40. Okay, so this again is the type of work that I would expect to see on my students' papers. And then we're picking the number that, again, or the ordered pair that maximizes, so the one that gives us our biggest answer, and that was the 5, 0. So that's the one that we would write 5, 0 on the answer line. We can also ask you if to minimize. Minimize would be pick the one that gives you the smallest answer. And in this scenario, that would be the 0, 0, gives us the smallest answer. And so that's how you do a problem like number 13. Some things that I told my students to bring a highlighter tomorrow. So maybe when you're all done graphing, you can highlight the one section that's supposed to be darkly shaded, kind of like I did with my red marker on the screen right now. Your ID card works great as a straight edge. It's usually big enough to go across the entire graph. So those are some things that you can bring with you. Gavin, do you want to see just straight up graphing, or was this good enough? This was kind of a complicated graphing. And if anybody else has other problems they want to see, just let me know. I know the 3 variables were probably the most difficult. So if we want to do some more of those, or we can do some more of these shading things. Yeah, still inequalities though, right, with the shading. All right. If it's cool with you guys, I'm just going to keep taking ones off the quiz just because it's sitting right in front of me, and so that's the easiest place for me to get it from. Now I have to try to erase all this. Let's see what we can do. I can't even see what it's selecting. Let's see. I'm going to get rid of all of that. Get rid of none of it. Oh, it looks good. Sorry. It's very slow to erase. Okay, I think I gotta do one more and then we should be done. All right, so there were a couple on the front where you had to graph with shading. As you can tell from our quiz, we're not going to tell you when to shade and when not to shade, but there's a couple like hints about when you should shade and when you shouldn't. So first of all, if there's an inequality, like a less than or a greater than symbol, that's a shading problem for sure. And then secondly, if we don't give you an answer line, then that's a shading problem. So the shading problems, you'll never write me like a final answer. The final answer is actually just the graph. And we'll talk about that a little bit more when we graph. Okay, so you know what? Just like the back or number 13 from the back of the quiz, let's go ahead and change these to slope-intercept just to make sure that we're drawing nice, accurate lines. Okay, and so we'll do this one in green. So I'm going to start at the -3. Oh, wait, let's make the pen a little bit bigger. Okay, we'll start at the -3. My slope is -1/1, so down 1 and right 1, or up and left. And then on the shading problems, you need to remember to like check and see if it's a solid line or a dotted line. I didn't really talk about that on the previous problem. But you know, if it's got this or equal to down here, it's a solid line. Okay, we're going to see how this works. Oh my goodness, that made it even worse. And if it does not have the or equal to, then it's a dotted line. So that's something you have to be aware of. Because if you don't draw the right type of line, you're going to lose points. And then I have my students always do a test point to see if it's see if the test point is true or false, and that kind of tells us where the shade. So I like to use 0, 0, and we just plug it into the original problem. And we see if it's true or false. So this will give me 0 is greater than or equal to -3, and that is true. If it's true, you want to start at the line and shade towards the origin. So I'm going to shade this way. I do highly recommend that you shade immediately after graphing your first line. Don't wait to shade until after both lines are on the graph, because that just gets really confusing. So I would shade as you're going. All right, so that was the first one. Let's do the second one. Again, I'm just going to really quickly switch this up a little bit. And we'll graph this one in gray. So I'm going to start this one on the +3 on the y-axis, which is up here. This one also has a slope of -1/1. Now I want to point out that if this was an equal sign problem, if this was not an inequality problem, and I had a slope that was the same slope for both of them, then these would be parallel lines. They still are parallel lines, but they would just be parallel lines with no shading. And then on an answer line, because if there's an equal sign, there will be an answer line. On the answer line, you would write no solution. So if you graph equations, things with equal signs, not inequalities, and you get some parallel lines, then you're going to write no solution. However, if you have inequalities that are parallel lines, those are not always no solution. Sometimes those have an answer. because on an inequality, we're really looking for where does the shading overlap. So it doesn't really matter that the lines don't overlap. We're looking at the shading. I'm going to plug in my 0, 0 again, and I get 0 is smaller than positive 3. That is also true. So from my gray line, I'm going to shade towards the origin, which is below the gray line. And I can see that I do have an overlap in shading. The overlap in shading is happening right in between my two lines. And so I would, again, if I were you, I would bring a highlighter tomorrow or a pen or something, and I'm going to shade really darkly in this middle area. Okay, and then the other two areas can stay lightly shaded. Just going to throw a couple other things out there. Again, this type of problem will not have an answer line, so you're not going to write down like no solution, or you're not going to write down an ordered pair. Technically, this type of problem has an infinite amount of solutions because every dot in the darkly shaded area, every one of those dots is considered to be a solution. So there's not like one solution, there's a billion and a trillion solutions. Also, solid lines, dots on solid lines are considered to be solutions. Dots on dotted lines are not solutions. Okay, so we got to be a little bit careful with that. All right. I can do number 14 if you want. Again, I don't think there's going to be one that intense on your test tomorrow. I would not focus on number 14. But if you want to, we can definitely go over number 14. But if there's something else that you're also struggling with and you want to work on that, we can do that instead. I'm going to erase this one while we decide, and we can totally do number 14. I'm going to have to do it on this graph. Or we can do something different. Okay. Delete. Part E. Yeah. And actually that's very similar to like that's very similar to number 13. So if it's cool, I'm going to like really quickly go through parts A through D because you have to have done those parts to be able to do part E. So for part 1, just define your variables. I'm going to let X be the homer hitter, and I'm going to let Y be the big timber just because that's the order they were written in the problem. Your profit equation is very similar to that maximize equation from number 13. And your profit equation comes from the very last sentence. And so my profit equation is 17 for the homer hitters and 29 for the big timbers. So that's my profit equation. That's letter B. For letter C, we have to write down the part where we say this can only be in the first quadrant, which is x is greater than or equal to 0 and y is greater than or equal to 0. And then we got a couple other inequalities. These inequalities will always be less than. So the 0 inequalities will always be greater than. Because you want it to be positive numbers, and those are numbers that are bigger than 0. And then the other inequalities will always be less thans because like 80 is the maximum amount of time you can use. So we need our time to be 80 or smaller. Okay. And then same with the 50. 50 is like the max, 50 is where we max out. So I need it to be 50 or smaller. And then we would graph, and just like we talked about on the on number 13, you want to stay in the first let's make that a little bit thicker so you can actually see it. You want to stay in the first quadrant. So, oh my goodness. So we're going to make sure that we don't pass the y-axis. We'll make sure we don't pass the x-axis. And then so me personally, right, I like to change these. So I changed it to less than or equal to negative 8 over 5x plus whatever, whatever 80 divided by 5 is. Oops, 80, nope, 80 divided by 5, 16. So that one starts on, oh, I can't even go there. We're gonna pretend like we're counting by twos, guys. Okay, so we'll pretend like this is 16, and then we go down 8 and over 5, which is here if we're counting by twos. Down 8 and over 5 is here. Okay. For the other one, it turns into y. It's less than or equal to negative 2 over 5x plus 10. So 10 would be here if we're counting by twos. And on this one, we go down 2 and over 5. There's my intersection. Down 2 over 5, down 2 over 5, and down 2 over 5 again. And so here's this. And again, on these problems, you're usually looking at like this area right here. All right. Okay, so now we're to part D. And on part D, this is where we write the ordered pairs for the vertices. And again, there's 4 vertices. My ordered pairs are 0, 0, 10, 0, 5, 8, and 0, 10. And you're actually going to use the ordered pairs from part D, and you're going to plug them into the profit equation from part B, and that's how you do part E. And so we're going to plug in 0, 0, and that's 0, which 0, 0 is never going to give us a very big answer. And then we do 17 times 10 plus 29 times 0, and that gives me 170. Next, we'll do 17 times 5 plus 29 times 8, and that gives me 317. And then finally, we'll do 17 times 0 plus 29 times 10, and that gives me 290. So this is what, for me personally, this is what I was expecting from my students on line E. And we kind of talked about this on number 13 as well. Like over in the blank space, I want to see that you took these 4 ordered pairs, you plugged them in to this equation, and you figured out what they equaled. And in the problem number 14, since we're trying to maximize our profit, we're going to choose the one that gives us the biggest answer, which would be 5 for X. And earlier we said X was homer hitters. So 5 homer hitters. 8 for Y, and we said that Y was the big timbers. And it gives us a maximum profit of $317. Okay, so that was number 14. You know, it's very similar to number 13. It's just number 13, we already gave you all of your equations and inequalities. And on number 14, we didn't. But the process is very similar for both of those. All right. What else? What else do you guys want to work on? We've got 15 more minutes, so we can do a couple more problems. If they're the 3 variables, we can probably only do a couple more, but whatever you guys need. So we can do some more 3 variables, some more graphing. You can go to your single login where you see all the like little icons for like all the little icons, and then one of them is for Pearson. So that would be where you can get to the extra credit quiz. So for me on the shading problems, I always do a test point of 0, 0. And so I'll plug 0, 0 into the problem. And then if it's true, that means I'm going to shade towards where the 0, 0 is. And then if it's false, I'll shade shade away from where the 0, 0 is. And I can kind of show you that. Let me erase what this is, and we can do another one of those to kind of check that out. Yeah, sure. If you have your textbook, we can look at some from the textbook. I actually told my students some from the textbook that would be good problems to work on because they're odds, and so the answers are in the back of the book, which really helps if they actually have the graph plus the ordered pair that you're supposed to use. So that those would be really good to do. So that was section 3-4. So if you turn to section 3-4 in your textbook, then you can find we can find some more problems to do. Before we do that, let me just really quickly show you how to figure out where to shade. I'm just going to do a single variable. Okay, so on this one, not single variable, single equation. On this one, I would graph at the -6 for the x and the +4 for the y. This is a dotted line because it's just a greater than, it's not a greater than or equal to. So dotted line like this. Okay, and then what I tell my students to do, I tell my students to plug in a test point. I like to use the test point 0, 0. I should probably do that in a different color. And so here is 0, 0 right here. And what I'm going to test is if it is true or false. So if it's true, then it's considered to be an answer, and I want to color on top of that dot, like I want to shade on top of that dot. And then if it's false, then it's considered to not be a solution, not an answer, and then I don't want to color where that red dot is. So I'm going to plug the 0 in for the x and the y. And the beauty of using 0, 0 as your test point is that like everything on this side of the equation just turns into the number 0. And so now I have 0 is greater than 12. And well, that's false. 0 is not greater than 12. So that means that 0, 0 right here, that's not a solution to this problem. And so I don't want to color that. So what I normally tell my students to do, I'll tell my students, put your pencil on 0, 0. If it is false, hop over the line, and you're going to shade this side of the line. If it's true, you just put your pencil on the dot, and then you shade on top of the dot. So that's how you can kind of tell where to shade. You can pick a test point and see if it's true or false. If it's true, you want to color on top of it, and if it's false, you want to color away from it. I hope that helped. Cool, awesome. All right, I'm gonna erase this, and then if you have your textbook, I'm gonna be looking at, I don't know what page I'm on, page 161. And let's just let's dive into number 17. Okay. So I'm looking at page 161, number 17. If you don't have your book, I'm going to write down what it is. But this is where you can find other good examples of those problems like number 13 from the quiz. I would say that like 17, 19, if you go back to number 15, all of those are good sample problems, again, that are very similar to number 13 from the quiz. And if you pick an odd problem to do, to practice, those have the answers in the back of the book, including the graph. So the back of the book will have what the graph should look like, and it'll also have like what your final ordered pair answer is. All right, so I'm going to spread these out a little bit. Oh, that one kind of sucks. You know what? Maybe we don't do number 17 because I think it's got some pretty nasty answers. Sorry, the y-intercept was going to be a decimal, and that's we won't do that to you on the test. Actually, I'm going to do number 15. 15. Okay, 15 is an error analysis, but we can still pretend like it's just an actual problem. What's really nice about number 15 also is they're already in slope-intercept form. It's kind of nice for us. All right. So the first thing I noticed when I was writing this down is it's got those inequalities where it's like x is greater than or equal to 0 and y is greater than or equal to 0. And so those two inequalities right here, those tell me I want to stay in my first quadrant. Now, I do want to be very clear, those are not always in the problems, right? It is possible to do one of these problems where you don't have x is greater than 0 and y is greater than 0. It's mandatory for word problems because we don't want to make negative amounts of things. Oh my goodness. But if it's not a word problem, we don't have to write those. So if these are not written in the problem, then don't graph them. Only graph them if they're written in the problem. So we're going to stay over here and here. All right. Okay, let's graph this first one, which is starting at the positive 6 and a slope of negative 2 over 1. So down to here. That is a solid line. We're going to pretend like it's a straight line. All right, and then just like on the previous problem we were doing, I'm going to plug in a test point. So I'm going to test 0, 0. So I get 0 is less than or equal to 6, right? Because negative 2 times 0 is 0. And that's true. 0 is less than or equal to 6. So from the red line, I want to shade towards the origin because we decided that the origin was an answer. All right, I'm ready to graph my second line. My second line starts at the 3. And it has a slope of positive 1 over 1. So I'm going to go up 1 like this. I'm going to go ahead and go this way too because it looks kind of weird to me. That's also a solid line. Oh my goodness. Like this, okay? And then I can plug in my 0, 0 for that one as well, and I will get 0 is less than or equal to 3, also true. So from my green line, again, I want to shade towards the origin, which is down here. And excluding these two, well, actually, no, you know what? Including those, you know, if we count, we have 1, 2, 3, 4 inequalities. That means we're going to get a 4-sided shape. And that means we should get 4 ordered pairs for the 4 corners. So you can totally count the inequalities to see like how many sides there should be. So if there's 3 inequalities, you'll get 3 sides. So you'll get a triangle. If there's 4, you'll get 4 sides. I mean, if you guys did the pizza problem in your class, that had 5 inequalities. That was a 5-sided shape. So however many inequalities there are, that's how many sides there are. And for this one in particular, we're going to start down here on the origin. We're going to go up till we hit the green line. Then we'll change direction. We'll follow the green line till it hits the red line. Then we'll change direction. We'll follow the red line till it hits the axis again. And then we'll follow that back over. And we're looking very specifically at this region right here, where I just colored in with the black marker. Okay, and looking at that region, I have my 4 corners. So I have my origin, 0, 0. Up here, that is the ordered pair 0, 3. Over here, that looks like 1, 4. And down here, that is at 3, 0. Then we're going to read the directions because that's important. And the directions say that they want to maximize. So we're looking for big numbers. And the equation they gave us was negative x plus 3y. So I'm going to plug each of these in. So negative 0 plus 3 times 0 is 0. Negative 0 plus 3 times 3 is 9. Negative 1 plus 3 times 4, that's 12 minus 1, that's 11. And then negative 3 plus 3 times 0 is negative 3. So if I'm looking to maximize, I would pick this ordered pair because 11 was the biggest of those numbers. If I wanted to minimize, I would pick this one because negative 3 is the smallest of those numbers. So really important that you're paying attention to the wording. Maximum versus minimum, those mean very different things. All right, guys, we got like 3 more minutes, so I can answer quick questions. Definitely can't do a 3-variable problem in 3 minutes, but if you have any last-minute, like, random questions that you that I can answer quickly, I can answer those. So go ahead and feel free to type them in. Ooh, that I don't know. I mean, it's got to be about the same length as the quiz, right? So it's on that really big piece of paper, and usually it's just like, how many can we fit? How many can we fit on that space? You know, we do try to make sure that you have enough time to finish. I do suggest tomorrow getting to your class as quickly as possible, so don't like dilly-dally in the passing period. And then if your teachers are like me, like I collect stuff before we take the test, right? So like I collect my kids' notebooks, and I collect homework that hasn't been turned in yet for credit, right? And so the earlier you get there, the better, so that you have time to like turn all of your stuff in and kind of like set up at your desk. And then, you know, for me, again, if everyone is set up and ready to go when the bell rings, I mean, I can put out the test as soon as the bell rings, as long as everybody's ready. I would say no more than 2. So the same as what the quiz had. There's no way we would give you more than 2. They will definitely be on there. Yeah, so 0, 0, as long as your line does not go through the ordered pair 0, 0, I would use 0, 0 every single time. It's the easiest mathematically to do, and it's also the easiest to find on the graph, because you have to find it and decide, am I going to color on top of it or am I going to color away from it? And plugging in zeros to an equation is super easy math, so we have less opportunity to make mistakes. I mean, that's up to you. If I had to plug, so here's, you know, in this example, again, that's currently on the screen, when I plug 0, 0 in here, this side turns into a 0. That goes away completely, and this side turns into just a 6. If I had to plug in 1, 1, I would put a 1 where the y is, and then I have to think, okay, negative 2 times 1 is negative 2, and then I'm going to add a 6 to that, so that's going to make a 4. And so, you know, again, in my opinion, plugging in zeros just makes things disappear. 0 is less than or equal to 3. It is an opinion. It's not like the law. So if you like 1, 1 better and you want to use 1, 1, absolutely. As long as the line that you drew doesn't go through the dot that you're using as your test point. That's the only restriction. It can't go through the line that you drew. Awesome. You're welcome. You're welcome, guys. I hope today was helpful. If you, I couldn't tell if people logged in on time or not, but if you logged in late, you know this is being recorded. It'll be up in like the next 5 minutes or so. So you can always go back and watch it again, or you can watch the parts that you missed if you need to. And good luck on your test tomorrow, guys.